In question 7, we're given a polynomial g of x with 3 roots alpha, beta, gamma, and we're asked to find the sum of the roots. We're asked to find alpha plus beta plus gamma. And this is a fairly simple question. We can just use the sum of products formula, sum of roots of a function formula, and that formula is basically the second degree term. So in this case, the coefficient of x squared, which is minus 7, it is minus 1 multiplied by that, so times minus 7 all over this coefficient 2, which is just 7 over 2. So the sum of the roots is simply just 7 over 2. Now for part B, we're given a polynomial of degree 5, h of z. We're also given that alpha, beta, gamma are the roots of h of z, and we also have another complex function p plus 3i, which is a root of h of z. And if p plus 3i is a root of h of z, we know from the conjugate root theorem that p minus 3i is also a root. And we're asked to show that p equals 1. So we can once again find the sum of the roots. So we can do alpha plus beta plus gamma plus this, and we know that would be equal to 11 over 2. So I can say alpha plus beta plus gamma plus p plus 3i plus p minus 3i equals to 11 over 2. We know that alpha plus beta plus gamma is simply 7 over 2. So 7 over 2 plus, this is p plus p, 2p, 3i minus 3i is just 0. So 7 over 2 plus 2p is 11 over 2. And that means 2p is 11 over 2 minus 11 over 2, which is 4 over 2. 2p is 4, so p is 1 as required. In part C, we're given that h of a half is 0, alpha is less than beta, and they are both positive integers, and gamma is a rational number. And in CI, we're asked to find what alpha times beta is. So since we know that gamma is a rational number, and h of a half is 0, one of the roots is a half, and half is a rational number, so gamma must be a half. So I'll say gamma is equal to a half, and we can use the product formula, so we can say that alpha, beta, gamma times p plus 3i times p minus 3i must be equal to minus 20 over 2, which is the product of roots formula. So I'll say multiply by 1 plus 3i times 1 minus 3i is equal to minus 20 over 2, which is 20 over 2, which is 10. And that implies that alpha, beta, we know gamma is a half. 1 plus 3i times 1 minus 3i is going to be 1 squared minus 3i squared, which is 1 minus 3 squared, which is 1 plus 3 squared, which is 10. So alpha beta times 5 is 10, so alpha beta must be equal to 2. Alpha beta is equal to 2. Very nice. For part B, we're asked to find the value of alpha and the value of beta. So we know that alpha plus beta plus gamma is 7 over 2. Gamma is a half. So I can say that alpha plus beta plus a half is 7 over 2. 7 over 2 minus a half is 6 over 2, which is 3. So alpha plus beta is 3. We know that alpha plus beta is 3, and alpha times beta is 2. Since alpha times beta is 2, we can either have alpha is 1 or beta is 2, or alpha is 2 and beta is 1. But we know that alpha is smaller than beta, so therefore alpha must be 1 and beta must be 2, which implies that alpha equals 1 and beta equals 2. And that's our answer.